Alright, welcome back. The next process we used for factoring was solve by taking the square roots. As always, I start off with trying to find out if there's a greatest common factor. That is, there is a number that goes into all number or variable that goes into all of them. If not, next step, get the squared term all by itself. Take the square root of both sides. Remember that you will have two answers, both a positive and a negative, and solve it. So let's see if we can do one of those. I have the quantity x plus 4 squared equals 121. My process says find the greatest common factor. There is not one. I got my squared term on one side with my squared on the outside. Don't do anything other than what you learn to do, or it will get very ugly. At this point, I can just go ahead and take the square root of both sides. Well, I know when I take the square root of this side, all that happens is that goes away. The square root of a squared number is just that thing right there. And I'm going to have two numbers, plus or minus the square root of 121. Well, 121 is a magic number. The square root of 121 is 11. Plus or minus 11. We made a few mistakes doing this. That's why I wrote it down like this. I need to make sure that you see that you have one answer is x plus 4 equals positive 11, and also x plus 4 equals negative 11. You will have two very different answers. I solved that for x. Inverse operations, subtract 4. 11 minus 4 is 7. I subtract 4. I subtract 4 from negative 11. Somebody borrowed $11 and they borrowed 4 more. They borrowed $11 and they borrowed 4 more. Yes, they owe you $15. Those are my two solutions. That is where this would cross the x-axis. That is the solution to this quadratic. Those are the zeros. Let's take a quick second and look at this other one, because there's more algebra involved here. When I do this, I do the reverse order of operations. That is, I do PEMDAS backwards. So, I know some of you are inclined to divide that by 2, but that's not the best method. The first thing I'm going to do is subtract 4 from both sides. So I got 2 times this quantity equals 12. How do I get rid of that? That's 2 times that. Well, I can multiply by the reciprocal or just divide by 2. If I divide both sides by 2, I got x minus 1 squared equals 6. Now this is just a straightforward square root problem. I take the square root of both sides again. When I take the square root of this, the square root of a number squared is just that thing. I have two answers, plus or minus the square root of 6. Well, I can't break 6 down because that's 3 times 2, and those aren't perfect squares. So to continue solving this, I want to get x all by itself. I use the inverse operations. I add 1 to both sides. I get x equals. I cannot add this 1 to that 6 because those are apples and bananas, and we're not making a fruit salad. So one of my answers is 1 plus the square root of 6. The other is 1 minus the square root of 6. Those are my two answers. Those are the zeros. And that is how you solve taking the square roots.